welcome to the next lab of the modern science. So today we want to go through the density driven flows. So I just go through the short part that what you need to do for today, and then you can go through this methods, and you can do all the calculation based on what you need to do in each part. Okay, so first of all, what we want to use today is preparing the salt solution. What we're using, this is the sodium chloride salt, and based on the table that provided in your method here, we need to go through 4 different concentration: 15 gram per liter, 30 gram per liter, 45 and 60 gram per liter. So what we did here, I already prepared the solution. So this is the green one, is 15 gram per liter, and 30, 45 and 60. The main thing that you should think about it is this solution, the volume of this solution is 2 liter. So what do you need to do for preparation this solution? Instead of 15 gram, you double the amount for 2 liter solution, because basically this concentration is for 1 liter. Okay, so we added some diluent just to you can have a better view of movement of the salt water. Okay, what we have here is the thermometer and the stopwatch. As you know, you need to estimate the speed of the salty water when it moves. So you need a speed watch to check the watch, to stop the watch, and thermometer for checking the temperature of the ambient solution and salt water. The ambient solution is the just normal water that when we go through it, you can get familiar with it more. You wanna stop? So what we're doing, we need to fill this, we use this barrier to separate the tank for the salt water from the ambient solution. So we just put it in some special places, and we keep it same, because we need to have like the same amount of water and same amount of salty solution during whole experiment. Okay, so I start from the green solution, that is 15 gram per liter. So I add this solution here. And then okay, so what I did, I filled the first part of this tank with the 15 gram per liter salty solution, and I fill the other part of tank, the rest of the tank, with the ambient solution that is like just normal water, tap water, and it should be at the same height. Okay, so the next step is checking the temperature. So for salty solution, the temperature is 19.5, and for your ambient water is 19.9. The next step is releasing the barrier, and then you need to record the time from the time the salty water start to move and hit the end of the tank. Okay, and for calculating the speed, the distance is equal by the distance between the barrier and the end of the tank, that is equal by 72 centimeter for whole experiment. So I release the barrier, and at the same time, when the salty water starts to move, we record the time.
16 seconds 50.
So look at the movement of salty water, and you should calculate the speed of this salty water. So for this concentration, that is 15 gram per liter, we repeat it 3 times. So now I just show it to you once, and you can refer to provided data in the table for all the data. Now I add the salty water. Let I add a bit more. Okay, so I added the salty water, the 30 gram per liter in the first, and this is the ambient water. And we have the record of the height of water, that is 18 centimeter of the water, that is same in both sides. So I slowly release the barrier, and then by the time we're recording the time for calculating the speed of the salty water. Look at the movement of the salt water. Stop.
12 seconds 72.
Okay, the third concentration is 45 gram per liter, this blue solution. So at the first part, the temperature of the salt solution is equal by 18.8, and the water, the ambient water, is 17.1. Now I'm going to empty this salty solution to the first part. Okay, and then I will gently release the barrier. But before that, for checking the height of the water is equal by 18 centimeter. Okay, now I gently release the barrier. 3, 2, 1. Yes. Stop.
7 seconds 78.
Okay, the last concentration is 60 gram per liter of NaCl. So at the temperature of ambient water is 18.8, and the temperature of the salt water is 18.8. At the salt, extra water to go to the same height. The height of water and salt water is 18 centimeter. So now I gently release the barrier. Ready? 3, 2, 1.
6 seconds 97.
of your report, you need to have a table. So all of the things that we did in the lab today, you will end it by 3 rep of each concentration of the salt, okay? And you will end it by 3 times. So what you're doing, you should have this table in your report and prepare it. So writing your time in front of each, and then average of timing. And based on that time and the distance, the distance is for the length of tank from the barrier to the end of tank, when the salty water, when the color water is moving. So you need to divide this distance by second of each timing that you recorded and calculate your speed. After that, you need to enter all the ambient temperature in your table, and then based on your ambient temperature which you have, you need to refer to this link, and based on that link you need to calculate the sigma T for your ambient and for your salty solution. When you did it, you should draw the table, the graph, which is based on the density and salinity. So for each salinity, you will have 1 sigma T, and you draw the graph, and also you add your ambient solution in the same graph. Another graph that you need to draw it is about the speed and salinity. So for each salinity that you did in the lab, you need to calculate the speed and draw the graph. Okay, thank you so much for today.